Hello there. I'm Teacher Im and I prepare videos to help my students score better in their STPM Maths paper, and I hope my videos can be helpful for you too. Let's get to the topic. Today's lesson is going to be about curve sketching using asymptote. Before I can do that, we need to know how to use limit to get this asymptote. I will start with vertical asymptote. So vertical asymptote is actually a straight line that cuts the x-axis and which are perpendicular to the x-axis. And we are going to use formulas, limits like this. And we read this as x coming from the right-hand side of A. So which means you have to imagine when you are calculating that x is coming from the right-hand side, and because the answer is positive infinity, so the answer that you are going to get will be bigger and bigger and bigger and so, following the arrow. Let's see the second one. The second one, we have limit where x is coming from the left-hand side of A. So you just imagine those numbers that you are filling in into your function are from the left-hand side, and the answer is keep on going smaller and smaller. So you have the arrow going down. Let's look at second case. Now let's say if x is coming from A plus, which means it's coming from the right-hand side, and when you calculate the function, okay, you put in the numbers and you calculate, and you notice that your answer is negative infinity. So which means whatever number you fill in, the answer is going to get smaller and smaller as it goes negative infinity. As for this one, if x is coming from the left-hand side of A, means A negative from the left-hand side of A, and you created the answer is x is infinity, means the answer is getting bigger and bigger and bigger. So we will put in the arrow as so. We will imagine our numbers will get in that pattern. Alright, so for vertical asymptote, most of the time we will use these two standard limit formula to fill it in. Means we need to create an A and know whether the A is going from the right-hand side, is coming from the right-hand side or coming from the left-hand side. So now you will be asking me, well, teacher, what's the A? Okay, what's the A? So the A is, let's say if we have a rational function like this, okay, the A, most of the time we will refer to the denominator. There might be 1, 2, or 3 values of A. So what we do is we take the denominator and we will let it be 0. Then we will create x values from it. So if there is only one denominator, x minus 1, so we take x minus 1 equals to 0 and we get x equals to 1. Then that's our vertical asymptote. Now, let's look at what when we fill into the formulas. So let's say if I say if x is the vertical asymptote, then the value of A is 1. I want to know whether x coming from the right-hand side, because it's A plus, coming from the right-hand side, what do I get? So of course the answer you have to calculate, and I'm sure you all are good in your limits already because it's from chapter 1. So just in case you don't, let's fill in. Okay, you can fill in some numbers like this. Okay, if you can't imagine the values, you just fill in. So x is coming from the right-hand side. okay, which means it's coming from a big number going smaller and smaller and getting very near to 1. So x is coming from the right hand side of a, so it is going to get nearer to 1. As it gets nearer and nearer to 1, you will notice the number goes bigger. So our answer is positive infinity. So you can imagine it, or you can actually fill it up. You can also use your calculator to calculate and imagine those numbers coming from the right hand side of A, and you put it into your calculator and you will get the answer too. So to get this, since we know that x equals to 1 is the vertical asymptote, so we can draw it. So x coming from the right hand side of A, can you imagine the arrow? So the arrow is going upwards like that. So let's say we have another one, because that is from the right hand side. So let's check out the A from the left hand side. So now when I put in any values of A from the left hand side, which the value most of the time will be left hand side of A, so the numbers are getting smaller and smaller and very near to 1. Okay, so we get -2, 0, and then 0. Actually, it's getting bigger because it's coming from the left-hand side, and the left-hand side is supposed to be smaller, so it's get bigger and bigger. All right, so we imagine those numbers and we fill it in, and we will notice that our values will get big, very small. The values will get smaller and smaller, like so. Okay, so we have here will be the arrows is going to be like this. Okay, so as the number gets smaller and smaller, from the left hand side, if the values are coming from the left hand side, okay, so the answer will get smaller and smaller. You got what I mean? Okay, let's check another case. Right, so that's our sketch. So, and of course, the perfect graph only will appear when you have the value labeled nicely, the graph labeled nicely. Okay, let's check out this case. Now, this one is for horizontal asymptote. When we fill in limit to the positive infinity, and when we calculate the function, and we notice that it becomes L. L means the graph that you are going to get will get very near to the value of L, but it won't touch L. Okay, and X is actually moving to positive infinity. This is second case for horizontal asymptote. So this line over here is horizontal asymptote. How about this one? X is moving from moving to the negative infinity and is getting very near to M. So we read this, X moving to the negative infinity means the value of X is going to the negative infinity, and the answer that you get is very near to M. This will create a horizontal asymptote, which is a line which cuts the y-axis and perpendicular with the y-axis. Right. Let's check this out again. This is a formula for horizontal asymptote. So you have limit x moving to positive infinity or moving to negative infinity, and you will get the same number. I'm going to use back the same example to save time. So I have this, but I'm talking about the horizontal asymptote this time. So what I'm going to fill in is the formula for limit x moving to positive infinity. Moving to positive infinity. And you will notice I wrote here 0 plus. So why 0? Because if you look at your limit, a number divided by x is supposed to get 0, means divided by infinity, a very big number at the bottom, you are supposed to get 0. That's from your chapter 1. But then here I wrote 0 plus. 0 plus means, you see, when I wanted to fill in x coming from positive infinity, x moving to positive infinity, I actually have my arrows can be at these two. Both of them also can. But then I have to confirm whether the arrow should be the top one or should be the bottom one. So to get that, you either imagine those numbers from positive infinity, or you can fill in the table like so. Okay, fill in the table. So you have two, you have to choose one. So I fill in the table as I say x is moving to positive infinity, means x values will get bigger and bigger and bigger. So I will notice that all the answers that I get is a positive answer. That's why I say x is it is a x positive, means it's on the number, the values that I choose will be on top like that. Okay, let's look at the second one. What if limit of x is moving to negative infinity? If it is moving to negative infinity, here I wrote, of course, moving to positive infinity or negative infinity is going to get 0. But for this case, I wrote there 0, negative. Okay, so why? Because if it is moving to negative infinity, I have two choices. I have to choose my choice. So when I fill in the numbers, for example, I fill in the numbers moving to negative infinity, I will notice that the answer that I get will get very near to 0 and from the negative side. So which means the arrows that I'm going to choose is the one at the bottom. So it is moving towards 0 and it is from the bottom. So with this, we conclude that y is equals to 0 is actually our horizontal asymptote. Are you following? Well, leave me some kind of comments in the comment box if you understand or you don't, so that if you feel it is hard to understand, please tell me. I will try to get this in a better explanation. Okay, let's look at some examples. Okay, so that is my graph which I had just now, and don't forget to label the graph. Okay, let's look at some shortcut method, because when you are doing limit, you can't calculate the limit in the long working that we learned in Sem 1. So most of the time, we try to use shortcut to create the answer of our limit when we are sketching graph. Except if in the exam question, the question actually asks for the limit first, and they gave some kind of marks like 2 or 3 marks for that. And then they ask you to solve the graph, okay, to draw or sketch the graph. So if the question is like so, means they ask for the limit, means you have to calculate using the full concept of limit. If not, if they just ask you to sketch the graph of the rational function, then you can use this shortcut. Okay, so there's two types of question, don't get me wrong. One is when they ask to calculate the limit and then use the answer to sketch the graph. So if they ask you to calculate the limit, then the full working of limit have to come out. But if they just mention sketch the graph, then limit can use this shortcut. I've already thought about this shortcut, but I'm going to repeat it again. So the first thing I'm going to do is the degree check for degree of numerator and degree of the denominator. If you see that the degree of the numerator is smaller than the degree of the denominator, the convention way is you use the limit technique and you check for the highest power of denominator and you take it and you multiply to all the elements in the question. Then you will get 0. Okay? And of course, this time, as you know, because you need to choose your arrow, you must know whether the answer that you get is a 0 positive or 0 negative. Okay? So let's look at these examples. So all of these examples, you will notice that the degree of the numerator is less than the degree of the denominator. So we know that the values that we are going to get is confirmed limit will be 0. So is it 0? Why do I write 0 plus? Press in the calculator and then you will notice, okay, press in the calculator and then you will notice that all these values, when it is coming from negative infinity, you will put into the square is going to be a positive value at the bottom. Okay, and negative infinity times with a negative number, you will also get a positive value on top. So the values that the answers that you are going to get forever will be a positive value. So this value you have 0 plus, means the value will come from 0 from the top side. Okay, so the arrow is from the top. How about this one? This one is I have limit moving to positive infinity, and again, because these are very big positive number and this is also a very big positive number, therefore I get my 0 from the right hand, from the positive side. Okay, means top of the 0. So when we get limit moving to positive infinity, we actually will create a y equals to 0 is the horizontal asymptote for both these cases. Let's say if I have the degree of the numerator is equivalent to the degree of the denominator, then the limit is actually the ratio of the leading term. So what does this mean? Okay, if you use the old way, we look for the highest power of the denominator, which is x power of 3, and we will multiply it with all the elements there. Now we will get negative 3 over 2. But this time, we must know whether it's negative 3 over 2 plus or negative 3 over 2 minus. Means we want is this horizontal asymptote coming from the top or the bottom of that value. So I have more examples here. You have limit x moving to negative infinity for the first one. So you just imagine this number is squared. These infinity numbers are squared. The top one is squared and the bottom one is squared. So they have the same element. Okay, so the ratio will be 2 over 3. That's what I wrote here. And the value is negative 2 over 3. So the value that I'm going to bring is negative 2 over 3. But whenever I put in the negative infinity, it will transform to positive. But because of the negative, so I get a negative answer on top. And I get a positive answer at the bottom. So which means whatever answer I get here is always at the bottom. So that's why I say negative 2 over 3 from the bottom. So it will get from the negative values. Alright, how about this one? This one I am moving to positive infinity. Okay, so both of them are positive. So these are very big positive numbers. And the ratio will be 8 over 3. That's how I get it. The ratio of the highest power will be 8 over 3. and it is the right hand side because all the numbers that I create when I put in, it should be a positive number. Okay, so I put 8 over 3 plus. So I will say that y is equals to the ratio of leading terms is going to be the horizontal asymptote for these two cases. Now there's another case like so. Okay, there is another case. Now, so what are going to be is the degree of the numerator is bigger than the degree of the denominator. Okay, so for this case, right, we will notice that when we deal with this question, you will get answer like this. It's going to be positive infinity or negative infinity. You cannot get a number or a zero. So for cases like this, we will call it the oblique asymptote case, where we will get our answer as some equation. Okay, let me verify. So let's look at this type of case. The numerator has power which is bigger from the denominator. So what we are going to do is we are going to set in long division. If you do not know how to do long division, please check out the videos that I have for SEM 1, okay, long division, and the videos I will leave the link on top, right? So we will set in the long division and we will write in like this. Means this is the quotient, the answer that you get from the long division. This is our divisor and this is our remainder. Okay, that's our remainder over there. Right. So once I get that, I will create my values of limit. Okay, I will calculate my limit. As you know, as the limit becomes, no matter it becomes a positive infinity or a negative infinity, you will notice this side over here, okay, will always turn from 0 to 0. As you learn your limit in chapter 1, it will transform to 0. So if this side are transformed to 0, then our asymptote that we create is not a vertical asymptote, nor is it a horizontal asymptote, but we call it an oblique asymptote, which means it is actually a straight line. Okay, so that's for the first part of my video. Okay, then in the second part, I will talk about how to apply all this to create the graph. Okay, so I will see you in the second part of this sketching of graph video, and we will talk about examples on how we are going to use this. I hope to see you there. So, how was it? Do you like what you see? Well, if you do, please hit the subscribe button and give me a like to support me, Teacher Im, to do more videos for you. And I hope in my next lesson, you will get more values from me. If you need any videos like so, please click on it. Bye. See you next time.